Welcome to Lecture 29, 5.2 Systems of Linear Equations in 3 Variables and Applications. So first, we're going to identify solutions to a system of linear equations in 3 variables. So just like how we try to identify what a quadratic equation looks like, remember, we look for the little x squared to identify the quadratic equations. And then linear equations, we just have x and y to the 1 power. And then exponential equations, we have a number to our variable in the power, and so on. So it's always good to learn to identify the different types of equations because we have different ways of solving them. So what does a 3x3 linear system look like? Well, it's similar to a 2x2 system, which we've been working with, but instead it has 3 equations. And another thing about these equations, there are 3 variables. So oftentimes, this one's just going to be an example, but you might have something like 2x plus y plus z, the new variable we're introducing, equals 1. And then I'll just make up a few other examples. So negative x minus 3y plus z equals 5. And then maybe, now not all variables have to be in all the equations. We might have something like 2y minus c equals 3. But one thing to note, the reason this is a 3x3 is there are 3 equations, and there are 3 variables being introduced total. So this is a 3x3 linear system. Now, one thing that we know, for 2x2 systems, the answer is 2 lines on a plane, and perhaps they cross, or something like that. That's if we're working with a 2x2. We're just looking at 2D. But when we get into 3 equations, that's when we start looking at the 3D world. Okay? We're not actually going to be graphing in 3D. That would be if you're going into calculus or something like that. But if we were to graph it, we'd be using the 3D coordinate system plane, which just sort of imagine a cube, right? If I was to place like an ice cube on the table, you'd start to get something that's 3D. Okay, and this is when we start having the x, y, and z plane. So the question is, what would the solution to one of these be? Because remember, the solution for a 2x2 was where the 2 lines intersect, right? The question is, what's the answer for a 3x3 linear system? What are we looking at there? Well, if you are in a room right now, try take a look at the corner of your room. Okay, so for example, if you're sitting at a desk, and then maybe off to the corner of your room, you can look up and you can see your ceiling right above you, and then you have one wall, and then you have another wall. So the answer to a 3x3 system will be where all these walls intersect. So where the ceiling and the 2 walls intersect. And what point is that? Well, that might be this point right here. That could be a solution to a 3x3 system. Okay, so think of a 3x3 system as the corner point. Now, once again, we don't actually graph these in Math 103, so this is just sort of a visualization of what we're getting at. So now, how do we actually solve them? So solving linear systems of equations in 3 variables. First, you're going to write all 3 equations in ax plus by plus cz. I had to remember what comes after c, d. Form. Okay, so very similar to the other time, you just pretty much line them up alphabetical order. X, Y, Z, A, B, C, D. Next, what you're going to do is you're going to pair off the equations and eliminate the same variable from the groups. This will give you 2 new equations. So somebody might say, well, why do we need to eliminate the same variable from both groups? Well, the reason for this is because, let's say that I had my 3 variables, x, y, and z, and I got rid of one of them, let's say maybe z. Then I would have 2 new equations and only 2 variables, which we know how to solve. And that's great, because we already know how to solve that. So that's our goal. We want to get it, sort of slim it down to just 2 variables. Okay, so step 2 is where we eliminate one of the variables. Usually we pick z to eliminate, but there are some variations, but usually I'll pick z to eliminate. And then one thing, note, because we only have 3 equations, one equation will be paired twice. The lucky equation gets to be used twice. And it's up to you which one you pick, but you just have to make sure that you are pairing them off. Step 3. Pair up the two new equations and solve like a 2x2 system. And 4. Use the two variables from step 3 and substitute into one of the original 3 variable equations and solve for the last variable. Answer in x, y, z form. Okay, so very similar to the coordinate set, but this time we have a z included. So we have the new member of our team, Z. Welcome him. Alright, so these might be a lot of steps, but let's go ahead and put them to action. So here we go. We have, oh, that should be a plus sign right there. Please go ahead and edit that with the equation. Alright, so how do we know that this is a 3x3 linear system? Well, first things first, we have 3 equations, 1, 2, 3. What else do we know? Well, we also happen to have 3 different variables. So we have x, y, and z. Okay, so this is a 3x3 equation. Let me go ahead and put that plus sign back. So what's the plan? Well, the first thing we're going to do is write them in x, y, z form. Well, notice they're all in x, y, z form, so step 1 is done. So then step 2, we're going to pair them off. And the question might be, which ones to pair off? Well, usually I like to pair off the one that has the smallest number next to the z. So this guy right here, that z has just a positive 1. So this one I have chosen to be the one that will be paired up twice. And you'll see why in a teeny bit. So I'll go ahead and pair them up. Let's see, 3x plus 2y plus z equals -7. And then I'll go ahead and set the other guy up to pair it up. Now you might wonder, why do I keep using these braces? Well, the reason is so I know that this is a system. If I had, let's say, something like this, 2x plus y equals 7, and then I kept solving and I did y, so maybe I subtracted 2x from both sides. How do I know that I'm solving or if this is a system? How do I know these are 2 different equations or if they're the same equation? Well, the way that I know is I put the brackets. If I see brackets, I know that these 2 are technically 2 different equations. If I don't include the brackets, to me, it'll look like you're solving something. So please, when you're showing your work, especially on the exam, use the brackets when you're working with 2 different equations. Alright. So we have that one that we're going to pair up with everyone else, and then we go ahead and write down the other ones. So we have the 2x minus y plus 5z equals -7. And then, let's see, x plus 4y minus 2z equals 1. Let me go ahead and color code these so you can kind of see where they came from. So this is the yellow guy, and then we have green and blue. So that's where we paired them up to. Remember, yellow gets paired twice. Now the biggest problem, or the biggest errors that I see students make on these tests are all the positive and negative signs floating around. So please be very careful. Make sure your work is as neat as possible. Okay, so then what was the next step? Well, we're going to match the variable. So pair to match. Well, once again, this is just like the elimination that we were doing previously with 2x2 systems. We're going to pair to match and cancel the z's. So let's go ahead and magnify upon these z values here. I got a 5z and a 1z. Now this is why, oh, 1z, that's kind of funny. Alright, this is why I chose the z to the 1, not z to the 1, the z with the 1 in front of it to be duplicated, because it's really easy to multiply 1 by any number. Now if we want to match these z's, I'll go ahead and make them both look like a 5z, which means I'll just multiply the top equation by 5, and the bottom equation, I don't need to multiply it by anything. It already has the 5 next to the z. So that'll be 15x plus 10y plus 5z equals -35. And then I'll go ahead and copy the bottom one down. Nothing happened to the bottom because it was already a 5z. Now let's go ahead. Should we add or subtract to cancel this? It looks like we should subtract. So that goes ahead, cancel the z's. Awesome. And then we get 15 minus 2x. So that'll be 13x. And then 10 plus y. So that'll be 11y equals, and let's see, -28. Alright, so I'm going to go ahead and box this. Why do I box this? Because this is one of my new equations in only, look at this, 2 variables. Awesome, we've gotten rid of z. So we're going to go ahead and do that on the other side. Let's see, let's go ahead and focus in on these z values once again. I want to match them. Well, I could make them both -2's. Let's go ahead and do that. Or I could make them 2's. It's up to you kind of how you want to do that. It depends on if you want to work with the elimination mindset or the subtraction mindset. Or sorry, the addition mindset. I'll go ahead and make them both -2's. So to do that, I need to multiply the top one by a -2. And then I get -6x minus 4y minus 2z equals 14. X plus 4y minus 2z equals 1. Once again, we do nothing to the bottom. It already is a -2z. And then, let's see, to get rid of these z's, we should subtract, because those will cancel if we subtract. So then, subtracting away, we get -6 minus 1, -7x. Then the -4 minus 4y, -8y, equals 14 minus 1. The 14 minus the 1, that will give me 13. And I have my 2 equations in 2 variables. So, step 3. Let's go ahead and check again. What is our step 3? Pair up the 2 new equations and solve like a 2 by 2. So we have 13x plus 11y equals -28, and -7x minus 8y equals 13. Now the plan, let's see, we could either use substitution or elimination. I think I'll go with elimination. Why not? So what should I eliminate? Usually I pick the variable that has the smallest numbers. In this case, they're both sort of large. So I'll go ahead and just decide to eliminate the y's. Now, to eliminate the y's, I have to find the common number for both of them. 11 and 8. I think the closest we can get would be 88. So I want to set it up so I have an 88y and an 88y. Well, to do that, I need to multiply the top by 8, and the bottom, I'll need to multiply 8 by 11. Once again, that means everyone in the equation has to be multiplied by the same values. So I'm going to go ahead and pull out my calculator because these numbers are getting large. It'll be 13 times 8, 104. 104, ooh, wait, let me change my pen color. 104x. My pen is feeling really slow tonight. Okay, there we go. 104x plus 88y equals, and then 28 times 8 is -224. And then 7 times that's a -77x, -88y, and 13 times 11, I used to have that memorized, 143. Let me check that again. 13 times 11, yep, 143. All right, now the y's are matched up. We can go ahead to cancel them this time. We have a positive and a negative, so we're going to go ahead and use the addition. And those cancel, and we're left with 104 minus 77, which is 27. And then the -244 plus 143. So 224 minus 143, we get a -81. And then, lastly, ooh, this is looking like it might end up looking nice. Divide both sides by 27. 81 divided by 27 gives me 3. Wow, that is actually really nice. It's a nice number. Okay, so we get -3. As always, box your work, you don't want to lose it. So how do we find y? Well, to find y, we'll go ahead and substitute this into one of the equations. I'll pick the bottom one since it's the smaller numbers. So this is for finding y. -7x minus 8y equals 13. Once again, you could use either one. We'll go ahead and use this. So we found out that x was -3. We'll go ahead and plug that in there. So we have -7 times negative 3 minus 8y equals 13. Once again, we're trying to solve for y here. So 21 minus 8y equals 13. Subtracting 21 from both sides. 13 minus 21. Let's take a look. 21 and 13, 8. Ooh, that is looking really nice. Divide both sides by negative 8, and we get y equals negative 1. Alright, so far, we have 2 of the answers. But we need z, remember? So what's the last step? Step 4, use the 2 variables and substitute in one of the original 3 to solve for the last variable. So one of the original 3, I'm going to go ahead. I'll use the yellow original 3. Why? Because it looks like it has the smallest numbers all the way through. So 3x plus 2y plus z, let me go ahead and write that down. 3x plus 2y plus z equals negative 7, I believe it was. Yes, and this was step 4. Alright, so we're going to plug in the x and y values. Let me just go ahead and highlight. So x is going to go there, y, negative 1 is going to go there, and we're trying to solve for z, the last variable. This is exciting. Okay. 2 times y, which is 1, plus z, which is negative 7. We get negative 9 plus 2 plus z equals negative 7. Negative 9 plus 2 is negative 7, plus z is negative 7. Ooh, these are all looking like 7s there. Add 7 to both sides, and ooh, what do you know? Z equals 0. Are we done? Almost, really close. We need to write our final answer. Remember, in the xyz form. So negative 3, 1, 0. That is our answer. The book might give different ways on how to answer, but this is the way I'll be looking for on your exam. Now let's take a look at using systems of linear equations and applications. So one thing to note, for 3x3 systems, there are 3 unknowns, usually generically x, y, and z. Though for word problems, we often use different variables. Alright, so Kelly from the Kailua Farmers Market, remember her from 5.1, decided that she should add a small size drink size to her menu and sell it for $2. She didn't change the prices for her regular size, $2.50, and the large, $3. Last Thursday, she sold 33 boba teas and made $79.50 in total. She sold the same amount of regular and large drinks. How many drinks of each size did Kelly sell? Alright, and there usually should be something here that says use a 3x3 system to solve. Alright. So once again, as usual for application problems, we need to do let statements for our variables. Since we're not actually given any variables, we need to write them down ourselves. So what are we trying to find here? We want to know how many drinks of each size she sold. So those will be our variables. How many drinks? Well, let's go ahead and say let x equal the small size. What else do we have? We have a regular size. So let y equal regular size. I'm going really generic here. If you wanted to do s for small and r for regular, you totally could. I'm just going generic. And then z will be large size. And I'll go ahead and put a drink to be a little more specific. Alright, we have x, y, z. Now the next thing. Whenever we set up our system, one thing to note is each equation usually stands for some type of a unit of measurement. What do I mean by that? Well, each equation is either talking about money, maybe miles, maybe number of items, or some other sort of relationship. But usually these are some of the main ideas you'd start to get. Maybe there'd be one equation in terms of dollars, one equation in terms of the number of items, and so on. So it's good to always group your given information in that way. So one of the first things that I see in this equation, in this word problem, is that we're told she sold 33 boba teas. That means the number of small, regular, and larges should equal 33. So if I add them up, they'll be 33, right? So x plus y plus z should equal 33. Those are her small, medium, and larges added up. Okay, so that was the number equation. Okay, we have 1 down, 2 to go. What other information have we not used yet? Well, we have a lot of dollar signs going on, so I know we should be able to do something with dollars. So her small was 2, her regular was $2.50, and her large was $3. And another dollar sign right here. So these 4 should be tied in somehow. Well, we know the total amount of money she made was $79.50, right? And how would you get that? Well, you would multiply the number of smalls by $2, then the number of regulars by $2.50, and I'll go ahead and do 2.5, and then the number of larges by $3. How do we get that? Once again, if let's say I told you I sold 5 drinks at $2 each, how much money did I make? Well, you would just take your number of drinks and times it by 2, right? So it'd be 5 times 2 is 10. If I said I sold 6 drinks for $2 each, how much money did I make? Well, you just do 6 times 2, which is 12. So the same idea is here, is if I said I sold X number of drinks for $2, how would I find out how much I made? I would just do 2 times X. Alright, so we've done 2 equations. We need 1 more. What other information have we not used yet? Let's see, last Thursday she sold 32 boba teas, made $79.50, and she sold, the same amount of regular and large drinks. So regulars are y and large is z. They should be the same, right? Y should equal z. Oh, that's a teeny eensy weensy baby equation. But it is what it is. Okay. Let's go ahead and solve. So the first thing to always do is we want to make sure that our equations are in the xy plus z form. And the last one is not. That's just y equals z. So I'm going to go ahead and change it to be the right form. I'll do the subtraction, so y minus z equals 0. And now we're going to go to step 2, which is to pair them off and cancel. And we're going to cancel z. So you could choose to stray from canceling z if you wanted to, since notice, in the bottom equation we don't have any x values. So we could, if we wanted to, we could pair up the top 2 and cancel x. That's a way to do it. Too bad I can't ask you guys which version you want to do. I'll go ahead and stick with the normal plan of canceling z. So to do that, let's see. I'll go ahead and use the bottom equation twice. Why? Because it's the simplest one. Always use your simplest one as the doubling. And then on the bottom we'll have x plus y plus z equals 33. And then 2x plus 2.5y equals plus 3z equals 79.50. And I'm actually going to change the top equation. I'll scoot it over a little bit so it lines up. Now, the next thing we're going to do is figure out how to cancel the z's. Well, for the first grouping, we don't need to do much. They're both 1s in front, so we just need to figure out how to add or subtract. So to cancel these, it looks like adding will do the trick. So if I add, the z's will cancel out, and I am left with x plus 2y equals 33. And there we go. We got 1. Now let's look at the next grouping. To get rid of these z's, I'll go ahead and multiply both by 3. Not both, sorry, just the top one. And that will give me 3y minus 3z equals 0. 2x plus 2.5y plus 3z equals 79.50. You could get rid of the decimals if you want, but I'll go ahead and keep them for now. The next question, should we add or subtract these? Well, it looks like adding will do the job to get rid of the z's. Negative 3 plus 3, that's gone. So then I have 2x plus 5.5y equals 79.50. All right, we now have two equations. So we'll go ahead. Let me move some of my work up because I'm starting to get a little squished here. I'll move it to the side there actually and then erase some of this on the side. Alright, so next step, step 3, we're going to pair off the two new equations and solve like a usual system. So we have x plus 2y equals 33, and then 2x plus 5.5y equals 79.50. And I think I've decided I want to cancel the x's. Why? Because that one x only has a 1. So I'll go ahead and multiply the top and bottom, so the top and side by 2. Then I get 2x plus 4y equals 66, and 2x plus 55. So we don't do anything to the bottom to change it. It'll just stay as it is. Let me fix that bracket sign. It was a little small. So now, how do we get rid of the 2's? Should we add or subtract? Well, since they're both the same sign, we're going to go ahead and subtract. So 2 minus 2, that's gone. And we are left with 4 minus 5.5, so it looks like negative 1.5y equals, and then 66 minus 79.50. So that'll be negative 13.5. And I'm going to go ahead and erase or white out that red down there. So real quick, note that we do not cover objective 4. You can go over that, or you could ask me about it if you want. All right. Okay, so 13.5 divided by negative 1.5 would be 9. All right, so y equals 9. How do we find x? We'll go ahead and use one of the original equations. I'll use this one. As usual, if you're ever doing anything sort of odd on the side, make sure to label what you're doing, like finding x, so don't confuse it with what's happening up top here. Always good to label your work. So for finding x, we'll go ahead and plug the y into our equation. So x plus 2, we'll replace that y right here with 9 equals 33. This would be 9. All right. And then, so that'll be x plus 18 equals 33. 33 minus 18, I believe that's 15. Let's see, 33 minus 18. Yep, it is 15. So x equals 15. We're almost done. Last thing we got to do, we're going to go ahead and find z. To do that, so this is step 4. I definitely ran out of some room here. So for step 4, we need to use one of the equations above that has z. Hey, why not use that one? It's super simple and easy. Let's do it. Okay, so find z, we'll do y minus z equals 0, which means we just need to use y. So I'll go ahead and plug in y, which was 9. So 9 minus z equals 0, which means that 9 equals z. Now, how should we answer? Should we answer in the coordinate point system? The answer is no. It's a word problem. The question is, how many drinks of each size did Kelly sell? So I'll go ahead and write my answer up here. Kelly sold. My K looks a little weird. Let me fix that. So Kelly sold what? Well, it looks like she sold 9 of the large, 9 of the regular. Let's see that. 9 of the large. Oh, sorry. Yeah. 9 of the large, 9 of the regular, and what was X? X was small. So Kelly sold 15 small drinks, 9 regular, and 9 large drinks. Period. And there we go. And that is it for this section. Please email me if you have any questions or need help with the homework.